This is a demonstration of the Rate Adaptive Probabilistic MAC, RAB-MAC, developed at the Center for Advanced Computer Studies, CACS, at the University of Louisiana at Lafayette. RAB-MAC is an opportunistic spectrum management scheme for cognitive radio networks. We implemented RAB-MAC using the wireless open access research platform WARP. WARP is an FPGA board to which radio daughter cards are connected. The state machine of RAB-MAC is written in C++, compiled and downloaded to one of the two power PCs of the WARP board, where it directly interacts with the physical hardware implementation. In this demo, we transmit a video stream using RAB-MAC and demonstrate its performance and its impact on the performance of the primary networks. We create a cognitive radio flow using the two upper laptops, each connected to a WARP board. The WARP boards act as the wireless air interface that runs the RAB-MAC protocol. We transmit a movie from the cognitive radio node on the left of the screen to the cognitive radio node on the right of the screen. The cognitive radio data packet to be communicated is downloaded to or read from the WARP board via the Ethernet cable that connects the WARP board to the associated laptop. The middle laptop is connected to a spectrum analyzer to illustrate the activities of the used spectrum bands. We created two primary networks which are implemented by the two lower laptops. Each laptop is equipped with two wireless air interfaces. We tune one interface to channel 1 and the other to channel 7 of the 2.4 GHz ISM band. For the first primary network, we have the laptop on the left transmitting to the laptop on the right. Meanwhile, the right laptop is transmitting data to the left laptop for the second primary network. We use iPerf to generate UDP traffic for the primary network transmissions. We control the UDP flow rate to control the activity of the primary networks. With RAB-MAC operating on channel 1 and channel 7 and using channel 14 for control, you can see a video stream is currently being transmitted from the left cognitive radio node to the right cognitive radio node. Please notice the delay in displaying the received stream at the right cognitive radio node due to the buffering delay. What I will do next is that I will turn on the primary networks using the lower laptops. Each primary network will start by transmitting a UDP flow at rate 1.5 megabits per second, which is 1/4 of the channel capacity for the first 30 seconds. Then they will increase the rate to 3 megabits per second, which is half the channel capacity for the next 30 seconds. Finally, both primary networks will fully utilize the channel capacity by transmitting backlogged flows at 6.3 megabits per second. Please pay attention to the quality of the stream displayed on the right cognitive radio node. Also, note the amount of spectral opportunities represented by black gaps on the spectrum analyzer on channel 1 and channel 7. For the first 30 seconds, each primary network uses only 1/4 of the channel capacity. Therefore, the cognitive radio flow can use the remaining 75% of the capacity to achieve a high-quality video transmission. Due to the existence of a significant amount of spectral opportunities illustrated by the black gaps on the spectrum analyzer. Now, the primary networks will increase their rates to consume 50% of the capacity. Consequently, the quality of the video transmission is significantly degraded. This is because of the existence of fewer spectral opportunities depicted by the reduction in the amount of black gaps for the second 30 seconds. Now, the primary networks are transmitting at full rate, and as you can see, the video streaming has completely stopped due to the lack of any spectral opportunities. As you can see here, there is almost no black gaps on channel 1 or channel 7. When the primary networks stop their transmissions, we will see that the cognitive radio transmission will be resumed and the movie will resume after a buffering delay. Finally, we will look at the primary network performance. As you can see, for the first network, there is no outage as it was received 1.5 megabits per second, 3 megabits per second, and 6.14 megabits per second. Similarly, for the second primary network, also 1.5 megabits per second, 3 megabits per second, and 6.29 megabits per second were received. And this concludes our demonstration.